So thank you very much for the lovely introduction. My talk is one of the maybe only ones at this conference that is not directly related to Kubernetes, and I try to make it really not depending on Docker as well. Kind of a bit of a background story why I got to this topic. So I started using containers like, I don't know, 5-6 years ago. And before that, I was using like normal deployment methods, or back then normal deployment methods where you like use an IIS server on a Microsoft Windows machine or deploy something to an Apache running on a Linux server. And when I first came across Docker, I was like, oh wow, what is this magic thing doing? It's so much easier to deploy software, especially to define which ports I want to access in this container and how I get files into the container and how to get files out. And was like, okay, good. From now on, I will just use containers. Later on, Kubernetes came up, all the container orchestration stuff. But still, the question remained, how does it even really work? I mean, lots of people tell you stuff like, oh, you have this image, and this image gets loaded when you run something like Docker run. And there is stuff going on which is isolation, and you have lots of security added to this whole thing, kind of built in. But I never really got behind the whole story, how this works, if this is something which just an ingenious company named Docker came up with, or if this is something built into the operating system. Maybe this is just an emulation, for example. So I never really got behind this whole topic. So maybe for the start of the talk, I named the Docker exec without Docker, because I thought Docker exec is kind of like this really magic thing where I can just open a new shell inside my container or run list files inside a container, which is a very suitable tool for debugging. I think many of us used it to like see, okay, did I really put that file into the container? Did I set this environment variable? Or maybe just like restart Postgres inside my container. And I never really got behind how this exec really works behind the scenes. So for everyone, or maybe we do a quick question. So who knows what Docker exec is? Yeah, I was expecting this from a ContainerDays event. Actually, this talk was already held at a web developer conference, so I have this slide in place, and maybe for the guys online. So Docker exec is a way to run a command inside an existing container. You use it like the Docker. You use Docker exec, you give it the container ID and a command, and it looks kind of like this. So for example, you can list all the files inside your public Nginx HTML folder, or you can, for example, open an interactive shell and then just do stuff inside your container. And when you try to dig behind these things, or maybe another story, how I got into thinking what actually happens behind the scenes. So in my university course, there was at one point in time another round of talks or of sessions where you have to like present some technical stuff, and I was like, oh, I can talk about Docker, and I always wondered how Docker really works, and I'm kind of the guy who really can get into one rabbit hole down. Years after I started using the technology, and I thought this might be the great time to actually dig behind the scenes. And if you do this, you come across several terms, which is like, of course, you have Docker, then you have something called ContainerD, which was created by Docker, then completely open sourced, and you have ContainerD doing things like pulling images and talking to runc. Actually, there's another component, runc, which is then creating the container. Well, this doesn't make up a presentation for university, because this thing container is still like a term that has to be a little bit more defined. And if you dig a bit deeper, you get like, oh, a container is using Cgroups, and the container is using Linux namespaces. So I think maybe most of you have heard that there are things like Cgroups and namespaces. So who has heard of Cgroups and namespaces? Okay, great. Maybe now the question, who knows exactly how Cgroups and namespaces work? Oh, great. Then I hope I can add something to you. Because these are the for me, really the main building blocks of containers. These are the things that add like 80% of the isolation and the control that we have for containers is added by Cgroups and Linux namespaces. And in this talk, I'm going to demystify what these are and how we can use them without using Docker at all. So this is basically the thought that maybe the guys from Docker had back then. Okay, we can build containers. We already may be doing this in some sort of manual way, and we provide a command line interface, or we provide a tooling that makes it really easy to set up these containers. And when we look at Cgroups versus namespaces, the first question is, okay, how do they differ? And I think the easiest way to define it is that Cgroups are limiting processes in a way, so they limit how much resources a process can use, and namespaces are isolating processes, so meaning you can really define this process is not allowed to talk to this other process, this process has a whole other file system, for example. This is the differentiation between Cgroups and namespaces. I think this is what most might be familiar with, and it's also pretty easy to connect the dots how this is used then in Docker and in Kubernetes. So for example, we have the option to limit the CPU. We all know this. We can, for example, restrict a container to just use like one CPU or 500 milli CPUs or stuff like this. And then we have options to set memory restrictions, for example. Like my container is not allowed to use more than 2 gigabytes of RAM, which is already pretty exciting because usually if you just don't use container, you will most likely not do this. And in containers, it adds a lot of security so that not one process can exhaust your whole system. Yeah, so there are many other Cgroups, like for example, the process ID Cgroup, which is not that relevant if you use Docker or Kubernetes. You can configure Cgroups for a container that you start, and you can configure the process ID. Cgroup, which is very interesting because the process ID Cgroup allows you to set a maximum number of processes that are executed within this group. So now you might think, why would I ever want to do this? However, if we think about, for example, security issues where this great example where someone opens a calculator from some remote code injection. So someone spawns a new process within your Cgroup, within your container, within your pod, for example. If you just limit the number of process IDs within this pod to exactly the number that you are using or that the application is using, no one is able to even open a shell. So meaning that something like Docker exec would also not work, obviously, because it opens a new process, the shell. But for example, this gives you the opportunity to really limit the number of processes that are running. Then we have, of course, I/O Cgroups, which are limiting how much bandwidth or IOPS you can use on your system. You can limit which devices and how it can access them. You have something called freezer, which is kind of funny. You can use freezer to freeze a process. So if there is a certain amount of process in a Cgroup and you set the freezer flag to 1, everything stops, which is also very interesting, I thought. And then you have lots of other Cgroups, of course. This is also like a controller architecture. We'll have a look at this in a minute, how this works on the file system level, how you set Cgroups. But for now, Cgroups are there to limit processes. So namespaces are isolating processes. And I think this is also very well known if you use Docker, and maybe you start using Docker and you want to set up a website and you use something like Docker run Nginx, and then you're wondering, there should be an HTTP server on port 80. Why I'm not able to reach it? And then you find this, oh, I have to forward the port like 80 to my local host 8080. And this is because there is a network namespace in place that completely separates the network interfaces from the container and my local host machine. And the same is true for my file system, for the process ID, so I can even isolate process IDs. I can isolate users. I can isolate time, which is also very interesting. So you can set a different time inside your container or inside the namespace to make it more general. The UTS is for setting the host name, which is also something everyone knows, because if you open a shell inside a container, you usually get another shell bash thingy on the left side before your prompt. And you have for inter-process communication also the option to open other namespaces or to isolate them via namespaces. So let's start maybe with Cgroups and dig a little bit deeper in how they actually work and how you can configure them. So for the CPU Cgroup, of course, limiting CPU resources, there is not much to it. You have two flags or two values, which is a quota and a period, and you use it that way that you define a share of how much time the CPU is allowed to consume within a certain period. So we have, for example, I can draw here. For example, you have like 20,000, I think, or 20 milliseconds, each 100 milliseconds, which is essentially 20% of the time. So this means like you can use 0.2 or 0.2 share of your CPU resources, which is also something what you can, for example, set for Docker Kubernetes. Then we have the memory namespace Cgroup, which is a bit more sophisticated. So we have, and this is also something which you might not know if you're just using containers, because you have this out-of-memory killer on the top level, which is what everyone knows. If you set a limit in Kubernetes, this is the out-of-memory killer. There is kind of like the guarantee that a process will not really overshoot the out-of-memory. It's not in like a total limit. There can be like a little bit of overshoot. Then we have this hard reclaim, which is defined like, so if a process allocates memory and it then frees the memory, it's not directly returned to the operating system, because it's an intensive process to allocate all that memory and do this virtual the virtual memory allocations. And so if a process frees memory or does not use memory anymore, it's just like kept at the process. And if you set this hard reclaim, it's really like everything that is freed from the process gets back to the operating system. And you have like this way of stepping it down from high to max to low. So the reclaim of the memory is not that aggressive on the lower ends. And you have also something which is interesting, for example, which is the min level. So everything below the min level is a guaranteed protection. So you are really guaranteed to keep that memory. This will never ever be returned to the operating system. And now you might wonder, okay, which of these values am I setting, for example, if I set a limit or a request in Kubernetes? So for the request, you're not really setting anything of these values, because the request in Kubernetes is just like an instruction to the scheduler. To give it a hint, I'm a very memory-intensive process. Please schedule me to a node which has maybe more memory. The one that you can set is the out-of-memory killer, and that you set with a limit in Kubernetes. So for the process IDs, I think I already explained everything. It just limits the number of processes inside your Cgroup. And for the I/O, it's also like you have like this max byte read, max byte write, max read IOPS, max write IOPS, which does allow you to define how many resources is my process allowed to use regarding file system access. And now, before we come to the namespaces, I want to show you a bit of a demo how this works. So I hope the size of my command line is appropriate for you. Great. The guy in the first row, this is perfect. So in the back row also, everything. Wonderful. So for Cgroup, it's like, when I first heard Cgroup, I was wondering if there is an A and a B group, and this was just very bad versioning. But turns out Cgroup is control groups. However, there is a versioning, and there's Cgroups version 1 and Cgroups version 2. Actually, I think Docker and Kubernetes shifted already to Cgroup version 2 and something around 1.25, or there's at least support for it. For today, we will be focusing on Cgroups version 2. I haven't dug into Cgroups version 1 very intensively, because you have to read a lot of man pages, and for reading man pages, you almost need a PhD in this topic, so was not inside of my scope. But for Cgroups, you have a file system place in a file system where this is managed, and this is inside the directory sys fs Cgroups. So for me, I'm using the Windows subsystem for Linux. And there, the Cgroups version 2 is mounted under this unified directory. And we get a lot of files. And I think we just look through them a bit. So we have something called Cgroups controllers. And this is what I mentioned. The Cgroups are working just like a controller architecture, kind of like admission controllers in Kubernetes. And we can have a look into this file, Cgroups controllers. So we have set a CPU set and CPU. We already talked about that, I/O, memory, process IDs, for example. So these are all the controllers that are available. In order to use a controller, we have to add the controller to this file here, which is the Cgroup subtree control. You can also have a look into this file. And there we see I already activated a CPU, memory, and process ID. You just add it like with a echo command, write it into this file, and it's working. If you do this, you might wonder, okay, so how then do I add a process to a Cgroup? Turns out you need to create a new Cgroup. So everything is running inside the root Cgroup. You cannot not use Cgroups. We can define a new Cgroup, for example, by just defining a new directory. And then we will change directory into this directory. And have a look here. So we see a lot of other files. Because we have activated them in the subtree control, we have access to the, for example, the CPU max. And we can maybe just have a look in CPU max. CPU max. So we see max and 100,000. So this basically means this is the quota, this is the period. So we define just everything of our quota is fine to use, so 100%. Nothing special about that. We also have some other files, for example, like stat, which offers me some statistics about the CPU usage in this Cgroup. We have all the memory files for defining the max, the min, the high, the low amounts of memory. We also have the option to define the max process IDs. Some of these controllers come with an events file, which you can use to subscribe to updates. So for example, if the out-of-memory killer is invoked, you get a ping in this file. And we want to test now if this really works for the CPU. So I will start a little stress test on my CPU, and we have a look at htop. So we can see it's using like almost 100% of my CPU resources, and now we want to limit it. So how do we do this? We could probably tell stress ng just to use 10% of my CPU, but we want to do it in a fancy way. So we have to set a quota. And we are going to do this by using an echo command. And we are writing just like something 10,000 out of 100,000 into my CPU.max. Wonderful. Let's check this. So now, does it work? Of course not, because we created a new Cgroup, no processes is within the Cgroup. We have first set a process into this Cgroup. So how do we do this? There is a file that is called Cgroup processes. And it really works like we just use the process ID of this process, which is, I have to guess. Yeah. We are using, I think it's the 844, and we do like an echo 844 into the Cgroup groups. Great. So if this process ID would not exist, I would also get an error message. And now we can see we have limited our process to around 10% of the CPU. And this is exactly what Docker or Kubernetes does. Or to be more specific, run C, which is the one who actually talking to the operating system. Great. And the other files just work in the same way. And you have the stats and the events, as I told you. So this is basically everything that you can know about Cgroups if you not want to dig into a kernel level, which I'm not the right guy for. So now we have a look at namespaces. As I told you, namespaces are there to isolate processes, which is very, very interesting because there are several different ways how they work. In Cgroups, we just have like, okay, we define some limits. In namespaces, it's like we have to unshare things. So for example, we can unshare the network. So the command that we use later on is unshare. Why it's unshare? Because just as with Cgroups, we cannot not use namespaces. Everything in Linux is already running in a new root namespace. And if we want to put a process in a new namespace, we have to unshare it from the current namespace. Funny naming. If we do this, for example, for the network namespace, it looks like this. We have a root namespace and some process, and this process has access, for example, to a loopback interface. So every process usually has access to a loopback interface. Every device or computer has a loopback interface. And if we unshare the network namespace, then we get a second loopback interface. And this is exactly what we observe if we use, for example, a Docker run and run a web server. We have completely different interfaces. Even if I bind this to localhost in my container, I don't have access on my local machine on the local host. And I have to set up some Ethernet bridges, for example. So this is the more advanced stuff. If you want to communicate between these two processes or between these two interfaces, you would have to set up a virtual Ethernet bridge, which is a component in Linux that allows you to define routings between two interfaces, just like if you can expect, like you plug a router between these two, but a virtual router, and then you can define how these are able to communicate. Which also means, because some people might not know this, if you have in a Docker file, for example, this expose port 80, this really is just a hint for the developer or the one using this image that maybe on port 80 is something running. But if you have an SSH server on your image, it's still available, this port. There is no firewall in place, because if I just connect these two interfaces, I can communicate on every port. And there were numerous talks at this conference. Great thing about network policies in Kubernetes. These are exactly the reasons why we need these things, because I can't do this with namespaces. So then we have mount namespaces, and mount namespaces work in a little bit different way. So if I unshare my process from the mount namespace, nothing happens. Because if I would get a clear or an empty root directory, there's nothing able to run. I don't have a binary in there. Would be kind of bad. So if I unshare my mount namespace, I just get the same file system as before. However, every change that I do from there on is being just done to my current namespace or my new namespace. So if run C starts a new container, it will unshare the mount namespace and then plug in this root fs, which is defined inside the container image. Then it will switch my root file system and then starts whatever process I want to start in my container. So same for process IDs. This is maybe the third way how namespaces can work. If I have process running on my root namespace, it might have a process ID of 1. It executes the sleep 30 seconds command, and I have a namespace where I unshare the process ID namespace, and I execute a sleep 40 command. So, and now I'm running the PS command inside my namespace, so for example inside my container, and I'm running the same command inside my root namespace. And what I can observe, at least if I'm root, we assume we are root because it's just easier. We can see in my namespace, I'm only seeing my process that is within my namespace with a process ID of 1. So process IDs aren't even that unique, because I can have a process ID of 1 in my root namespace and a process ID of 1 in my container namespace or my new namespace. However, this process ID in my namespace is remapped on the root namespace. So namespaces also have like this hierarchy. You can just like create more namespaces and like a tree. And however, the root has access to all these processes, because otherwise we wouldn't even be able to touch this namespace for any longer. So this is the third way. So we have something like in the network namespace where we get set completely to 0. Then we have the mount namespace where we remain the same way as we were before, and we are able to make changes that are not reflected in the root namespace. And for the user, for the process ID namespace, we have this like of a mapping, just like a virtual file system, the memory management. Okay, then for example, there's another namespace which is the user namespace, and this is also something very important for containers, because if we need root inside a container. We don't want to have root like in the rest of my system. Root is required to, for example, to use certain Linux capabilities like open ports below 1024. And so it might be required that I have root inside my container. However, I don't want to have real root. So again, I have here this kind of remapping from the users from my root namespace to my namespace inside my container. So here you can see in my container we have a file test2. Test2 was created in also this namespace. It has the permissions root. However, if we look on the root namespace, it's actually remapped to a user with the ID 1000. And otherwise, if I have a file created with root on my root namespace, which is actually root, it's remapped to a file with some other random user in my container. So this is how the user namespace works. And I think for the last ones, I don't have the slides in place because they are not that much important for containers. As I already told you, time namespace allows you to set different times inside your container. UTS is about the host name. We have the Cgroup namespace, which is obviously isolating different Cgroups so that not one container running a web server can mutate like the Cgroup of a database and just set my database memory limit to like 1 megabyte. And then we have inter-process communication, which I also won't touch now, but we can have a look at a little demo about network namespaces because this gives a really great overview of how actually these things, the isolation works. And for that, we will start with unsharing the network namespace. So, and as I told you, the command is really unshare, and we unshare the network namespace, and we open a bash inside this. So we spawn a new process and put it directly inside this namespace. Nothing really happens. We can check my devices. And I see I have a loopback interface here. So just for comparison, if I think we can quit this. If I do this on this machine, I have my loopback interface and my Ethernet. This device is currently down, so we have to set it up. Set dev loopback up. Now we can actually use this device, and we will just start a netcat on this with port 8080. So now let's communicate with this, and so it's running on localhost. I didn't specify an IP, so it's running currently on the only interface that it has, which is localhost. And if we try to communicate with this, for example, in this shell where I didn't unshare anything or joined another namespace, I'm not really able to connect to this netcat instance. 8080 minus V. So connection refused. There's nothing answering. So now what can I do? I can find out my process ID that I'm using within here, which is the process ID of the netcat, for example, because this process is also in this unshared namespace. And we will just do this. Might need sudo for this. And let's use this process ID here. And now we have another command, which is nsenter, much more logical name if you ask me, because this allows me to enter a namespace. And we can use a process ID for that, which already forgot, 871. And we, of course, have to specify we want to enter the network namespace, so -n, the network namespace, and we want to open a bash. Permission deny, great. Then we just use the developer's greatest tool. And now we are in the same network namespace, and we try to connect to the netcat instance, which is running on this port. This. So like hello ContainerDays, and of course we get the communication here. So we are actually now using the same loopback interface. We are in the same namespace, and we can just communicate. So great, how it's looking time-wise? Great, because now we can also do this, what I was most proud of, that I made it. and which is also why I call this talk Docker exec without Docker, because now we can just try to start a container and open a shell inside this container without using Docker at all. So for this, we are just trying to kill somehow Netcat. And then because I'm using Windows Subsystem for Linux and my Docker installation cannot work with Cgroups version 2 and I haven't figured out how I can tell it, I have to remove this from my subsystem configuration, which is currently forcing it to use version 2, and we are just removing that. Then we are rebooting the subsystem. Yeah, sure. So this is essentially just shutting down the subsystem, and now we can restart. So we wait to it to come back. There it is. We'll open just another sudo shell here, and now we should have our running Docker. Great. So now back to my notes. We just run a Nginx container, and I have some files here. You can have a look at them, HTML. Just like hello ContainerDays, we run this container, and of course we can curl it because we define the port forwarding. So we have a connection inside the network namespace of this container, and I have to use like the port 8080, and I of course get the response. Great. So now, maybe this is obvious, but I will do it anyway. So if I try to access the file, the index HTML inside this container, obviously does not work. There is nothing on my local machine. So now the question is, I can use, for example, Docker exec to get into this container. So we use Docker exec minus ID, which here, and then we use the container ID, and we use a bash. Great. Now we are in a container. We notice, oh, the shellbang just changed because we have this other UTS namespace, which allows me to set another host name inside the container. And we notice this is just set to the container ID. Great. And now I can, for example, also open the website on port 80. And I have the file my index HTML inside this directory. Great, nothing special about this. Now let's exit this container, ensure it's still running, yes. And now we want to enter this container without using Docker at all. There is a command which is lsns that allows me to list all the namespaces, and here we can see that this Nginx process has a mount namespace, a UTS namespace, so basically every namespace, so we just it just created its own or unshared every namespace that there is. And now we want to join it. So we can use this process ID, and we use the ns-enter with this weird kill child, which is somehow required, otherwise it doesn't work. We use we join every namespace, and we define the process ID, and we use a bash. No. A bash. What is it? I have the -a. There's no kill child in this enter. You're right. Great. So now we are in my container. You need some trouble with live demos. This is just because everything worked so great till now. This was really a requirement. Now we are inside my container. We see essentially we have the same look and feel that we had before. So this was the point in time where I realized, okay, the Docker guys are not emulating anything or forwarding anything inside my container or doing whatever complicated stuff. They're really just, of course, you have to get behind all this, that you can use it that way. They're just using this way of interacting with Linux namespaces. And of course, now I can, for example, we did this before, so this will not be a very big surprise, use port 80 to query the website. We can, for example, also look into wherever I place the file engines HTML. So we have my index HTML here, which we mounted inside this container. And we are essentially just like sitting inside this container as every other process. And this, I think, is a very good roundup of this whole topic, how Cgroups and Linux namespaces work, how you can use them, how they offer isolation and this limiting capabilities. And I hope this was somehow insightful for you. Maybe you will start to write your own container engine, which is something I'm looking forward to. And now, thank you very much. I know this stage might be now closed, but there are other talks to still enjoy. And please, if you haven't done yet, you can also follow me on LinkedIn. I post a lot of stuff also about generative AI, but because this is my next career step, basically. So thank you very much, and have a great rest of the conference.
Thank you so much, Oliver. We've got a couple questions, so I definitely want to go through them. So the first one is, can you configure Docker/K8s to use Cgroup v1?
So the thing with Docker and Kubernetes is I think that Docker isn't even more directly supported by Kubernetes. You had this Docker shim thing, which is communicating between or doing this container runtime stuff. So you're now using just like ContainerD, and you were even using, or maybe you might still be using Cgroups version 1 in Kubernetes. The version 2 isn't maybe out there for several years, but not really adopted now. So the answer is, of course, yes, you configure it. You can go backwards if you really like this. You can also configure it to use version 2, maybe the better idea.
Yeah. And then can an attacker abuse Cgroup to gain access or modify pods/containers?
Okay, disclaimer on this one, I'm not a security expert. However, can an attacker abuse Cgroups to gain access or modify pods container? So I'm sure you can abuse Cgroups, sure. So normally you don't have the permission to maybe, for example, change the memory limit inside a container. This would be a pretty bad thing, which is probably something what an attacker could do. However, this is also the thing, if an attacker, for example, gets root access to your cluster node or something like this, of course he can just like fiddle around with your Cgroups and modify parameters there. However, I don't think there's a real vector for privilege escalation. One of the things is using but this is namespaces then for users and the non-root and non-privileged containers. So I wouldn't say so directly, or nothing you have to worry about.
Luckily, good. So I found this one particularly funny. Can you also use kubectl exec without kubectl?
Yes, obviously. It's really just the same thing. So if you just want to get access to one of your containers running inside the cluster, you can do it without kubectl. However, you have this issue that kubectl also bridges the network, of course. So if you don't have SSH access to one of your cluster nodes where this container is physically running, you have to go this step over the API server. This is why it's there. This is why it's great, why we love it. But if you're sitting on the node, then you can totally use just like nsenter and go.
Great. And the last question, can I change memory request limits without restarting the pod using the memory max file?
Yep.
Oh, great. That's a great answer.
Yeah.
So give it one more time for Oliver Seitz, please, people.